examiner to have. Okay, so for brief but specific details of how the results will be used to obtain the amounts in moles of all the components in the initial reaction mixture, you just need to find the initial amount of propanoic acid, what mass you use, 6 grams, divided by the MR, you will get the initial amount of propanoic acid. The initial amount of methanol, same thing, take the mass divided by MR, initial amount of HCl, just take the volume multiplied by the concentration. Concentration here, I'm using 3, but this is the approximate concentration. By right, you should be using the accurate concentration that you found in bullet point 1. But because you never carry out the reaction, you don't know what's the exact concentration. Okay, so this will be approximately 3.00 times 10 minus 2. But if you know what is the exact concentration, you should use that here. Okay, just substituting it to show you that it can be done. And it will be what you need to show to the examiners also. Initial amount of water. In 2015, this wasn't shown for many candidate script. Okay, they thought that there was no product at all. Okay, but because HCl is a solution, there will be 10 grams of water present, which means that you can determine the amount of H2O. Okay? Alright, so you have this. HCl is your catalyst. Okay? Alright? The only thing that doesn't have any amounts of at the start is the ester. 0 moles of ester is formed at the beginning. Okay? The rest has got an amount that you can calculate. Okay? Then the next bit comes together, I feel. For part 2 and 3, what is the amount of propanoic acid present in the mixture at equilibrium? And what are all the other components amount at equilibrium? Okay. To me, I find that 2 is the most tricky part. Okay? Because what do you do to determine the amount of acids in the reaction mixture? The only way for you to do that is to do an acid-base titration. But when you do an acid-base titration using the standard solution of sodium hydroxide, in the reaction mixture, you not only have unreacted propanoic acid, you also have the acid catalyst that is inside. Okay? Since it is a reversible reaction, you know that this is what's going to happen. Both forward and backward reaction can take place. Okay? At equilibrium, if you let the average titer value of titration be V2, the amount of sodium hydroxide required for the acid-base titration at equilibrium will be V2 over 1000 times 1.00. So you will get this amount of sodium hydroxide. This must be equal to the amount of propanoic acid and the amount of HCl present at equilibrium. Right? Because when you do acid titration, all the acids here will react with sodium hydroxide. Okay? You know from the previous part 1, that the amount of propanoic acid plus the amount of HCl present initially is this plus this. We've calculated that before. Okay? Which means that the amount of propanoic acid that actually reacted in the reaction, forward reaction, will be equal to the initial amount, okay, minus of the amount at the end. Okay? Alright? Because in 0.111 it includes both propanoic acid as well as HCl. This is the total amount of acid at the start initially, minus off the total amount of acid at equilibrium. Only your propanoic acid would have reacted. HCl remains the same at 3.00 times 10 power minus 2 moles. Why? Because HCl is a catalyst and is constantly being regenerated. The only change in amount initially and at equilibrium is due to the propanoic acid that reacted. Okay, so you will know what is this amount of propanoic acid reacted. Okay? Alright, but this is not my answer to part 2. Okay? It's not my answer to part 2. Okay? To find my answer at part 2, okay? Alright? If you just let the amount of propanoic acid reacted be X, which you can find, okay? The equilibrium amounts of propanoic acid, methanol, ester and water can all be calculated together. The amount of HCl catalyst will remain the same because it's constantly regenerated. You know all this from part 1. Okay? The change, if you let it be minus X, plus X, plus X, there is no change in there's no change in amount of your H plus. Okay? Because it's a catalyst. Which means that at equilibrium, you will be able to determine what is this, this one no change, what is X and what is this. You know X because you have done the titration. Okay? From doing the titration, if I just go back, this is X. This is X. Okay? So if you can find this, you will know what is the value of X, which means that all of these values, you will know what is the numerical value using the ICE table. Okay? Alright? So this table helps you to determine and answer point 3. What are the equilibrium amounts of all the other components in the equilibrium mixture? Okay? Alright? Can? So what you need to do at the end, okay, they say that you need to do calculation, but I need to show how you can determine Kc. Kc is equal to the concentration of ester times water over concentration of carboxylic acid and alcohol. By right, you should be taking the equilibrium amount divided by volume, right? To find the equilibrium concentration. But because the stoichiometric coefficient of the reactant is exactly the same as the stoichiometric coefficient of the product, all the volume terms will cancel out because total volume is constant. Which means that equilibrium concentration of ester times equilibrium concentration of water over equilibrium concentration of acid over alcohol must be equal to equilibrium amount of ester times water over equilibrium amount of the carboxylic acid times the equilibrium amount of alcohol. So now I have shown how I can use these values to determine Kc. Okay? So now I have answered the bulk of the planning question. Okay? Alright? And so the main concept that is covered in this equilibrium question is just acid-base hydration. But I hope you can see how we can set a context on chemical equilibrium, requiring you to use information that you have learned before, which is acid-base hydration, and change the whole question in such a way that appears to be very, very different. appears to be very, very foreign, but actually we use the same concept through and through. Okay, so this will cover most of the marks in this planning question. Hello, hello. And the last bit, any relevant safety precaution you consider important. Very common feature in planning question. Okay, because the chemicals like propanoic acid is corrosive, you will use gloves to handle them. Likewise, you will not carry out the experiment, okay, near a naked flame because methanol is a flammable compound. Okay, that's also given in the table. Okay, conduct the experiment in a fume hood to prevent exposure to toxic fumes of methanol. Okay, if you breathe in too much methanol, it will cause some form of damage to your brains, and prolonged exposure will also hurt your eyesight. Okay, alright, so this is the planning question for 2015. Okay, you will see planning questions appearing for your end of year practical exam, okay, which will happen in term 3. Okay, we will have a promotional practical exam. So be prepared for planning questions. Okay, so on Wednesday we will continue with our last lecture on chemical equilibrium. Alright, so bring your chemical equilibrium lecture notes or pencil. I'll see you on Wednesday.